Hey gang, Professor Feeser here, and today we're talking about the IMS, or the IP Multimedia Subsystem. And this is still a big part of the training that I provide on 5G in the IMS, 4G in the IMS, SIP, and how can you talk about SIP without at least going into a couple examples of how telecoms are implementing the protocol. Ultimately, the IMS is a way for a provider to onboard 1 million, 10 million, 100 million subscribers and still have a system that's capable of scaling, still have a system that can interconnect to other IMSs. If you think about it, you're a Verizon customer. Sure, you might call some friends and family that are on Verizon, but at some point, you're calling somebody on AT&T or the US Cellular or T-Mobile network. So all of the major carriers have this platform, and the way it's set up is pretty much the same across the board. There's some unique flavors, there's some unique styles put into each network, but that's largely just based off of the vendors that they work through. That said, most vendors are trying to play by the rules because ultimately they want to advertise that their gear is compatible with 3GPP standards. A part of the standards program is also helping vendors create gear that they know could be sold around the world. Everybody's building the same service network to make phone calls happen. We're not going to talk about a phone call from Alice to Bob today. We're going to focus on Alice phone powered up. Alice phone has an IP address. Alice phone is ready to get service. That is to say, be in a send and receive ready state as far as phone calls are concerned. So let's just dive in right there. Here on the left, let's focus on that phone. We have an Alice phone that powers on. It uses whatever technology it uses to define IP connectivity, and we're going to start right here. In this phone service profile, which would be in its little brain, it's going to have knowledge of a PCSCF, a proxy call serving control function. 1, 2, maybe multiples that it should register to. As in, hey phone, we're not telling you about an SCSCF, we're not telling you about an ICSCF, we're not telling you about an application server, we're not telling you about anything beyond this wall. And the reason for that is folks are pretty clever. You start sniffing on that phone with a packet capture program, and you're going to see all sorts of IP addresses that probably should be super secret start to pop out on that device. Stuff that might be a serious security concern. So the PCSCF's job is understanding SIP, from the phone all the way to the PCSCF. Nothing else speaks SIP. So this is really the first device that could verify the SIP message is intact, verify that this person isn't trying to destroy the network and do a DOS attack with SIP, like here's 50,000 SIP registrations. It could, maybe if it's an emergency call, it might relay to an emergency service. It might also look at obfuscation. So on the way in, who cares? There's nothing to hide. But when we send a SIP message back, this guy will often peel out super sensitive info and just hold it and say, phone, you're on a need-to-know basis. Here's what you actually need to know. And it's usually the phone learns about this IP address, but nothing beyond it. So the phone drives a SIP message, and if you're going, well, what type of SIP message? There's a lot. It's called a SIP register. That's pretty simple, right? The phone's registering. It sends a SIP register. into the network. And the things it's going to have there primarily are its IP address and its IP address, so whatever access gave it, and also the thing called the address of record. That's what the phone company would know you by. And typically it's your phone number at the domain that you pay your bill to. So in this example, I have iris7.com. That's my company. But practically, it's going to be Verizon. VZW is Verizon.com, or it's going to be att-ims.com, I think is theirs, or I think T-Mobile is T-Mobile-ims.com. But it's very much a string of numbers at a domain. It looks like an email address in a way. That PCSCF, it cannot talk to the database, which, by the way, when the IMS is created, the database is called the HSS. In 5G, we've updated that. You'll see other names out there, UDR, for example. Not a big deal. It doesn't matter what you call this central repository. Ultimately, it has user profile information in it. So the PCSCF goes, well, I can't talk to the database anyways. I'm going to send the SIP register to this ICSCF, who's the interrogating call service control function. And when do you send to the ICSCF? When you don't know where to send it. I mean, the PCSCF wants to send this call to an SCSCF, a serving call service control function. The SCSCF is who makes the outbound and inbound calls possible. It's who actually holds the registration in the provider side of the network. The problem is, when we started, I said there might be 1 million, 10 million subscribers, which means you don't have one SCSCF. You have 10, you have 20, you have 100, you have 1,000. So which one are we supposed to put Alice on? That sort of information's in the database. So the PCSCF sends the SIP register to the ICSCF. The ICSCF uses diameter. That's a database profile. We'll talk about it someday. It uses diameter to query this database and gets back a response, diameter response. And that's very much the user profile, the user service profile is sent down to the ICSCF. And all they need from that profile is, where's the SCSCF we're supposed to send that to? So very much what would come back from that diameter query is like a primary, secondary, tertiary PCSCF to register to. That allows the ICSCF to send this registration now to there. So phone powers up, we hit the PCSCF, it sends it to the ICSCF, we make a query, where are we supposed to actually, who manages Alice's registration, response comes back, and then step 6 is the SIP register sent to the SCSCF. The SCSCF is skeptic. It says, look, I would love to allow Alice to make and receive calls, but I don't know that Alice pays her bill. I don't know that Alice is even a customer. We need to double check this stuff. So the SCSCF says, hey, I need a glimpse of that user profile as well. It uses diameter to grab the user profile. And it's not interested in where does Alice register. It's interested in, can you provide me with a challenge so Alice can prove to me she knows a password? Alice does not send her password into the network, ever. Alice sends a distillation, a mathematical proof that she knows her password. And to provide that proof, Alice is given a puzzle, like a math puzzle. They say, hey, solve this puzzle, and that'll be enough for us to, the only way to solve it's with your password. Just send us the answer to the puzzle, and if you can solve it, we'll know you know the password without sending it to us, like in the clear. So the SCSCF gets this information, it builds this little puzzle, this challenge, and it's sent back in a SIP failure code called a 401. A 401, which is called user authorization required. So the first SIP register gets back a 401, which is a failure, but it's desirable. We wouldn't want Alice to just be onboarded. That would mean people could just get free service from us. So what Alice does is she re-registers. And the only thing she provides now is an authorization line. And in that auth line, she's going to include the solution to this little puzzle that she was given. That's going to take the same path. Everything happens again. Nothing's cached, nothing's remembered. So it's the same lines to the PCSCF, from the PCSCF to the ICSCF, who asks the database, where are we supposed to register to? The answer comes back. The ICSCF sends it to the SCSCF. The SCSCF, it might actually cache the profile for a second, but it may grab it again. It looks at the challenge solution that's sent in. It goes, you either got it wrong or we'll say you got it right. If you're going, well, why didn't it just do that to begin with? It couldn't. The 401 carries with it the puzzle that you're supposed to solve. So you have to. The first registration is always expected to fail. You're really getting back this puzzle to solve ultimately. All right, so the second, we'll call it SIP register prime. That works. And you don't get a 401 back to that. The second register is sent a 200. And that comes back the same path. It goes from the SCSCF to the ICSCF to the PCSCF back to the phone. Now here's what's neat. We no longer need the ICSCF. Right? The ICSCF was because the PCSCF didn't know we need to send it there. Now look, I have another one over here. So maybe he was confused and like, well, was I supposed to send it over there? I don't know where to send it. Right? But we just had this 200 that goes back is Alice's home SCSCF, her service provider, saying, yeah, I will relay your outbound calls. I will relay inbound calls to you. No problem. So what happens is the SCSCF actually includes a description of itself in a special header in the 200 that goes back. It says, hey, here's who I am. Here's your service provider. Well, that goes back through the ICSCF. The PCSCF sees it and goes, hey, we don't want Alice, the person, to know this anyway, so I'm going to cache that. But even though I learned it by way of the ICSCF, I now know that I can send direct to you. If Alice sends a call to me in the future, I can send it direct to you. The PCSCF strips that information out, any other information, and it sends back this 200 response to Alice, and Alice just learns, okay, from the 200, I'm online. There's an expires in there for like an hour. Alice goes, okay, I'll re-register if that gets low. But Alice learns only about the PCSCF in front of her, knows that, okay, if I have an outbound call, or if I receive a call, it should always be through this particular PCSCF. All that's learned by the time this 200 occurs. So what we, in the future, when Alice makes a call, it's going to go up to the PCSCF and can go directly to the SCSCF. That's primarily it. But there's a few other things we should mention that are going to happen. The SCSCF is going to pass the successful registration up to the application servers. They will send back a 200, like, cool, we get it. We know what's happening. All the SCSCF is doing is saying, hey, Alice is online. You know, application servers provide features. So there may be features that act differently if Alice is online versus offline. Countdown to voicemail, for example. Just pulling one out. There's all of them could potentially work differently, but that's just one off the top of my head. How quickly you want to send a call to voicemail if it came in. Well, if the application server knows Alice is offline, we're going to send it there immediately. We're not going to bother to even page Alice. The application server does a diameter query as well to the database and gets back the feature set that Alice currently has. So again, this could be, does Alice even have voicemail? Is it set up? Are there certain phones that Alice doesn't allow calls from? Like there are blocked numbers, blocked at like the service level. Is Alice not allowed to make calls to certain country codes, to certain area codes? You know, did Alice's parents say, no more calling Bob? All that stuff would be profile information, would be features that are handled by the application server. Sometimes the application server even does normalization, caller ID normalization. So the call comes in as Alice, but the application server changes it to Alice Anderson +1 717 585 6333 would be Iris 7's number, but changes it so that it's formatted for the world to understand and see actually who Alice is. As an example, application servers can do anything. It's their job is providing features. Additionally, the phone's not done either. We have to do one other step, and it's a SIP step. It's kind of minor, but to understand it, you just have to appreciate something about SIP. The protocol was written from the phone's perspective. That is to say, a phone sends a register to the network. The network just says you're online or offline. Well, when a phone signs out, it does it also through a register. A phone signing out, it actually registers for 0 seconds. So it does the exact same thing we just talked about. It just says, hey, I'm registering for 0 seconds, and it's offline. Why would you do that? Well, because we just said, features act differently when you're offline. You want your calls to go straight to voicemail, for example. Or you want them to go to your buddy. The network knows to send them to your buddy because you're signed out. Well, that's not going to work for the phone network. The phone network wants control of their phones. So they force the phone to do something kind of bizarre, at least from a SIP standard. A SIP standard, not an IMS standard. An IMS-enabled phone is absolutely going to do this. A normal SIP phone wouldn't, but here it is. The phone sends a SIP subscribe That's actually the SIP message, gang. It's a SIP subscribe. And that goes from the phone to the PCSCF, and the PCSCF knows to send it right to the ICSCF. The ICSCF sends back a 200 along the same path. Here's what you got to know about subscribes. Subscribes include a header called event. And the event that the phone actually asks to subscribe to is called reg or register. And the 200 that comes back, which means, yes, you are successfully subscribed to registration events, actually has an expiry in it. It'll say like, yeah, for the next hour, we're going to tell you about your registration status. Here's why they do it. Should a manager get into the database, or an admin, manager, admin, somebody that wants to control this phone. Suppose they say, hey, something's wrong with this device. Something's wrong with this PCSCF. We need to take it offline immediately. Or let's even do a different one. Let's say Alice just stops paying her bill. We need her to stop receiving service immediately. Well, what we want is a button in our database that we can push and say, the following user or users are suddenly no longer having service. And what that would look like is a diameter message being sent down to a bunch of SCSCFs, one or more SCSCFs. The SCSCF going, oh my goodness, I just got message from a database that said Alice is no longer registered or allowed to be on the network. Well, the SCSCF can't send a register to it, but because that subscribe happened, it can send a notify. The subscribe allows a notify relationship. So the SCSCF would then create a notify, and that notify would say, hey, you know that event called register, reg, that we worked on a moment ago? Well, sorry to tell you, you're terminated. You're no longer registered. The SIP phone freaks out and goes, I have to be registered, but I was just told I'm not. So what does the phone do? It does what any good phone would try to do. It immediately goes back to this registration process. It goes, all right, let me re-register. And the whole story starts again. Why is that advantageous? Well, if you had to take one of your SCSCFs offline for firmware updates or maintenance, you go into your database and you say, hey, everybody on SCSCF number 1, for the next 12 hours, they're going to use SCSCF number 10. And then you push the button to kick everybody off SCSCF 1. Everybody loses service, but immediately they re-register. And when the ICSCF says, where do we send them? It doesn't learn SCSCF 1. It learns to re-register all these one or more phones to SCSCF 10. And in the event that Alice doesn't pay her bill, the re-registration happens when the ICSCF says, what SCSCF do I push Alice to? The answer back is no SCSCF. Alice has an outstanding bill to pay. The IMS just works at this point, gang. It's represented in most architecture drawings as a little cloud at this point. But if you do need to do a deep dive into the IMS, if you need to do a deep dive into some of those newer services, 5G, what's on the horizon for 6G, I'd love to be your consultant. Go ahead and give me a like, hit subscribe, and then reach out to me. My contact information's down in the comments section. I run classes, public classes each month. I'd love to get you into one. Thank you so much, gang, and I'll see you on the next episode of Code with Feeser.